All right, let's talk about Matplotlib. If you've ever used it in Python, you know it gets the job done. It makes charts. But making them look, good, that can feel like a whole other challenge. So today, we're going to go from that plain default plot to something that's actually designed and tells a story. Let's dive in.
And this all kicks off with a problem that, well, I'm pretty sure we've all been there. This user on Reddit just nails a super common frustration. You know the feeling, right? You write the code for a cool, interactive plot with a slider, you run it, and nothing. It's just a flat picture. We're going to figure out exactly why that happens, and a whole lot more. And yep, there it is. The classic default Matplotlib plot. I mean, it shows the data, technically, but it isn't really saying anything, is it? No title, no labels. It's the visual equivalent of a mumble. But here's the good news. We can fix this, and it's way easier than you probably think. Okay, so our first step is adding the most basic, yet most important elements to our plot. This is hands down the fastest way to add clarity and make your data actually make sense to someone who's looking at it for the first time.
You know, a plot without labels is kind of like a map without a legend. It's just lines and shapes. By simply adding a title and labeling our axes, we give our viewers the "you are here" sign they need to understand what they're looking at. It's really the bedrock of good data viz.
And check this out, the fix is so simple. Looking at the code here, we're just adding 3 little lines, plt.title, plt.xlabel, and plt.ylabel. You're literally just telling Matplotlib, hey, this is the title, this is what the bottom axis is, and this is what the side axis is. That's it.
And boom, just like that, our plot actually has context. It's the exact same data, but now it communicates something. We know we're looking at date-wise temperature. We see the date, we see the temperature. That's a huge improvement for, 30 seconds of typing?
But, okay, why stop there? Labels are crucial, but we can also make things look good. Matplotlib gives you an incredible amount of control over the aesthetics. We can change the line color, add markers to show the exact data points, and even switch up the line style from solid to dashed or something else entirely.
So by just tacking on a few more arguments right inside that plt.plot function, things like color, marker, line style, and line width, we can completely transform our simple blue line into something way more custom and, frankly, more interesting to look at. Each one is another little design lever you can pull. Okay, this is great for one plot. But what if you're making, a dozen charts for a big report? Manually setting the color, the markers, and the labels for every single one? That sounds super tedious. There's gotta be a better way, right?
And you'd be right. Meet style sheets. This is Matplotlib's secret weapon for creating consistently beautiful plots with just a single line of code. This is a game changer.
Just look at this transformation. Seriously. On the left, our old, bland default. On the right, that slick, polished 538 style, which you might recognize from the data journalism site. The difference is night and day, and it all came from one single command, plt.style.use 538.
And the best part is there are a ton of these built right in. You can get that R-inspired ggplot look, go for a dark background if you're making a presentation, or get the super clean Seaborn style. It's like having a professional designer on speed dial. It's definitely worth just playing around with them to see what you like.
Now, what's even cooler is that you can stack them. You can pass a list of styles, and Matplotlib just applies them in order. So here, for example, it would first apply the dark background, and then it would apply the presentation style on top of it, maybe making the fonts and lines bigger for a slideshow. It's just incredibly flexible. But what if you have your style, a look you want on every single plot automatically, without even having to type that style.use command every time? Well, for that, we have to go right to the source, the master control file. This is the Matplotlib RC file. Think of it like Matplotlib's DNA, or its main settings file. It's just a plain text file that Matplotlib reads every time it starts up, and it sets the default for pretty much everything. Figure size, fonts, colors, you name it.
If you want a set it and forget it solution, this is it.
So we've got 3 ways to customize our plots now, right? We can tweak them one by one, we can use a style sheet, or we can edit that main Matplotlib RC file. So how do they all play together? Like, which one wins if they conflict?
It's actually a really simple hierarchy. Think of it like layers. At the very bottom, you've got your foundation, the Matplotlib RC file. Those are your base defaults. Then, when you use style.use, that comes in as a layer on top, overriding the defaults. And finally, any changes you make right in your script, like plt.title, have the final say. They're the top layer and will overwrite everything else for that specific plot.
Now that we're basically pros at styling, let's circle all the way back to that initial problem from Reddit. Why wasn't that user's plot interactive? The answer has nothing to do with colors or styles, but something way deeper under the hood. The backend.
Remember, when the user checked their backend, this is what popped up. Backend inline. And that little piece of text, that's the smoking gun right there. It tells us exactly how Matplotlib is trying to draw the plot. So what on earth is a backend? The simplest way to think about it is this. It's the rendering engine. It's the part of Matplotlib that does the actual drawing. And different backends are built for different jobs. Some are made to create static image files, like a PNG, while others are built to open up a live interactive window on your screen.
And here's the mystery solved in one go. The user's inline backend is static. It's literally designed to just spit out a flat image inside a Jupyter notebook. That's its whole job. To get those cool interactive sliders and zoom features, they needed to switch to an interactive backend like Qtag or Tcag. A different backend means completely different behavior. And just like that, problem solved.
Phew! We have covered a ton of ground here, from simple labels all the way to the inner workings of backends. So let's boil this all down into a simple, straightforward playbook you can use on your next project. Here is your 4-step guide. 1. Need a quick one-off change? Just use functions like plt.title. 2. Want a consistent look across a whole project or notebook? plt.style.use is your best friend. 3. Want to set up your own permanent, personal style for everything? Edit that Matplotlib RC file. And 4. If your plot is acting like a dead image when it should be alive, check your backend.
At the end of the day, Matplotlib gives you all the tools you need. You can go from a generic, boring chart to a clear, compelling, and even beautiful visual. You're not stuck with the defaults. You're the designer. So the only question left is, how will you choose to design your story?